Here we are, 1 week from quiz 2. Is that right? So today we start chapter 3. Tuesday we finish chapter 3. Your quiz then on Thursday of next week, right?
Happy Valentine's.
Yeah. And then we only have like 2 weeks after the spring break, I think. Does that sound right?
Yeah, March 4th.
Boy, isn't that something? And after we already got like a week off. That's so great. We had a semester. Right? Chapter 3, I'm so glad you're here for it. People who are absent are going to be bummed out because this is one of the hardest chapters for some people when it comes to analyzing this output. Alright, so let's see, where are we going to start here? Let me show you this. This is chapter 3, ready? I'm going to show you this. Even though it doesn't look like I had it set up. Wait a minute. Right here. What is that one? Do you have any full size? That one? Here we go. Oh. Man. Can't win. Okay, there. Now you see this? This was from chapter 2. We're carrying on to chapter 3 with the same objective function, the same constraints. So it should look familiar. Remember that graphing? This was that straight up and down line, and this is the 19V8. This all looks familiar, right? Now, look at this. Where is it? No, not that. Hang on, this. Get that back. Where is it? Okay. That on the right is the output for this problem on the left. I want you to get familiar with this output, all the different parts to it. Now, we talked about certain parts of it already, such as the very top. At the very top, you see the words objective function value. That's where the optimal solution was plugged in here and here, which happens to be 5 and 3. And if you take 5 times 5 and 3 times 7, that'd be 25 plus 21, 46. There it is, at the top there. Right below that, where it says variable value, reduce cost, that's always where the optimal solution is placed for the variables. So the optimal solution for x1 is 5. The optimal solution for x2 is 3. Right below that are the constraints and their slack or surplus and what's called their dual price, which is, if we get that far, that's part of today, right here. But that is. Right below that are all kinds of numbers that are all about the objective function. Everything you're seeing in this area has to do with this. Okay? Everything you see in this area, called the right-hand side ranges, has to do with these. Let me repeat this. Constraints, objective function, constraints, optimal solution, objective function value. Everybody see those parts? Every software has these parts on there being communicated in different ways. And once you start looking at this and understanding these parts and what they mean and where to look for them and how they're calculated, you can read any software output. You're applying for a company and they'll may even ask you in the interview, hey, we're going to be doing linear programming, we're going to do production scheduling here, we need an analyst to do the math for us. What software did you use in college? And you'll say, oh, management scientist is the name of ours, I think. Management scientist? Oh, we use, I think it's called Lingo, something, something. You go, hey, you say, let me see an output. And you're gonna, if you get used to this, no matter which output you're about to see in an interview, you'll be able to understand it because it's telling you all the same information in different ways. Same stuff, different ways. I'm trying to think, here. See this output over here? Here's the constraints. Here's the objective function information. Here's more about constraints. There's the optimal solution. There's the objective function value. But believe it or not, you're looking at an output that's different in format than the previous one. Same information, but it's set up a different way. So you've got to get used to these headings because I may use 1 of 2 or 3 different outputs that we saw in this class, and some of them, the objective function coefficient is here instead of over here. This is telling you the allowable increase, how much that number could increase, which has a meaning, and how much it could decrease. But this output, again, doesn't have allowable increase and decrease. It has the current value, just like the other one did, But this has what's called an upper limit. If you want to know how much it could increase, you got to subtract these two. This could increase by 2, all the way up to 7. Allowable decrease, well, this is the lower limit. But if you subtract these two, you'll find the allowable decrease. So what I say this is 2 and 0.33. Does that sound right? So let's look at the other. Oh, it's a whole different problem. Okay, anyway, get what I'm getting at? Now let's go back to this one, Bill, just so we know what we're talking about here. Or is this it? Yeah, here we go. Here's the objective function numbers, not those numbers. Here's the allowable increase. If this were on this other output, that would be 5 plus 7. 12 would be the upper limit. 5 minus 1. 4 would be the lower limit. See how we interpret this? But it's the same information on all of these. Some of them have it even arranged completely different, where it's on the left and on the right. That's the same stuff. Now, let's go back to this. Are you ready? The reason this output is important, and the reason is, well, I'm trying to get across to you on how to understand this output, is because in real business, these outputs are used to make fast decisions. You know, they tell you so much information, and when things have to be changed, and when they don't have to be changed. Now, you're going to hear words that are like, how will this affect the objective function value? Will it have a positive effect? Will it have a negative effect? Look at the objective function value in this problem, and you see the number, help me out, because I don't remember 40-something. 46. Think about what kind of problem this is. If I said to you, it needs to have a positive effect on that objective function value, do you think I'm describing that it should go up or down as a positive effect? Why up? No, not because it's positive. Almost every one of them are going to be positive. But she's right. A positive effect would be going up, but why? Because it's a max. A maximization problem, a positive effect on that objective function value would be increasing it, because usually a max problem is all about profit. Profit or revenue or something that we want to be larger. So a positive effect would be making that 46 go up. Negative effect means that that 46 is going to be going down. These dual prices are either going to be positive or negative, and they're not telling you whether you should subtract or add. This is the most common mistake. They're telling you whether what's about to happen is going to have a positive effect or a negative effect. That's what this is telling you. These are connected to these. You guys getting this? You ready? These dual prices are all about the amount the right-hand side of the constraints could go up or down. I'm going a little fast. You can tell by the looks in your eyes. All right, I want to review just a little bit here. You ready? These are telling you whether it will have a positive or negative effect on that. If that's a positive 2, is that a 2? I'm still close, I can't tell. That means that if something happens down here that's related to that, is that a 2 or a 3, you guys?
2.
Okay. If something happens down here, which I'm going to connect in a minute, this is telling you for every unit that that other thing changes, it's going to have a positive effect of 2 units, in this case dollars, on that. And you got to say to yourself, positive effect. Okay, wait a minute. If this is a max problem, that means I'm adding 2 or 2 and another 2, depending on how many changes take place. And if this is a minimization problem, that positive effect means subtract. Because on a minimization problem, usually the objective function is all about cost. And a positive effect would be bringing it down. That's why we set the objective as a minimization, because we want it to be as low as possible. So don't assume you're adding or subtracting based on this being positive or negative. Assume that this positive or negative is telling you to have a positive or negative effect, and then determine what that means. A maximization problem, positive effect means add. A minimization problem, positive effect means subtract. You got that so far? Now, you ready? These dual prices represent the effect a change in any of these constraints, right-hand sides, will have on that objective function value. If the change goes up 1 unit. Boy, I said that nice and slow. I hope you guys already got that. You want me to say it again? if the change on the right-hand side of a constraint that that dual price relates to goes up 1 unit, this is the effect it will have on that objective function value. So now, look at that same 2. That 2 is connected to, jump in.
Oh, I'm just going to say, like, for the example you have up there, so like the one where it's 2x1 plus 3x2.
Which is this one right here, right?
Yes. So
Yeah.
say that 19 goes to a 20, you're saying it's going to increase the value to 5, 2.
Everybody hear this? Everybody hear? He's saying if this 19 goes up 1 value, 1 unit to 20, then it will have a positive effect of $2. This is a max problem, so a positive effect is we add $2. Our new objective function value is going to be $48. That's the effect this will have. But that dual price can only determine the effect as long as the change on that 19 is within the limits. Everybody hear that? Because he said it's going up 1 to 20, it's within the limit. So that is valid. So we could just add 2 up there, and we now know our new objective function value. But if it's going up 5 units, from 20 to 25, look what happens. It's the limit 24. This dual price is no longer valid. We cannot answer that question quickly. I'm sorry, I don't know what's going to happen, what these are going to be. I got to redo this problem because that change is outside that limit. Everybody hear that? Okay. Now the 19 is going down 1 unit. See this? Is it within its limit? What is the limit? Is that 10 or 18?
That's small for us.
You can't see it
I think
either?
it's
Tell me here again.
I think it's 18.
18? Okay. Here, you know what? Let me look at my computer. Yeah, it's 18. Did I say it's going down 1 unit? Is it within its limit? It's right on it. So it is. It's equal to it, so it's within the limit. But this didn't go up, it went down. The dual price for that one is a positive 2. But because the change went down, it's not going to have a positive effect, it's going to have a negative effect, the opposite of what the dual price says to do. Everybody hear that? Let me say it again. Any one of these changes go up, that dual price is telling you positive or negative effect. Any of these changes go down, you need to do the opposite of what this is telling you. So again, this 19 is going down to 18. I want to make sure you can picture this. I'm now going to paint a picture for you, more reality for you. Hey, we only got 19 tons of this raw material for this production that's about to take place. All right, or we even say 19 pounds, make it easy. 19 pounds. And we're supposed to be making 5 and 3 of whatever this is. That was the decision made. But 19 didn't make it. We've already started production and only 18 showed up. You know, should we stop production or what's the deal here? And say, well, let me see at least what the effect will have on the objective function value. This is not going up, this is going down 1 unit. For every unit of change, it's going to have a $2 effect. And it would be a positive effect if that were going up. We got delivered 20 pounds instead of 19, but we got delivered 18 instead of 19. Since it went down, it's not going to have a positive effect or 2, a negative effect. We got to look and see if this is a max or a min. It's a max, so a negative effect would be to subtract $2 instead of add. So now our new objective function is 44. I can't remember. Got to redo this and that, whatever. But anyway, you see what happened there, right? Everybody see how I calculated the new objective function value? Okay, now hang in there. We're far from done. In the middle is the objective function coefficient, the numbers with each variable in the objective function. In this case, 5 and 7. And there's some math done to figure out what 5 could go up to, what 7 could go up to, or down to. Now this is where I lose people, you ready? Any changes in the objective function numbers are directly related to the optimal solution. So the question is not going to be, well it is, but the question is going to be if there's a change here, it's going to say, hey, let's see, this is a max problem, so let's say these are profit. You know, our head of finance just came in here and said, we just found out from our supplier, I just got the bill from supplier, this raw materials cost us a little less than I expected, and our profit's not going to be $5 on every one of these X1s. It's really going to be $6. Does this change production? Are we still making 5 and 3, or do we need to change things? My question for you is the change from 5 to 6 within its limits? It is, because it could go as high as what? 7. Now you recalculate, okay, let me back up. Because it is within the upper limit, those two numbers are still valid. We're not changing production. Keep making 5 and 3. Get it? But the objective function value changes every time anything else changes. But we calculate the objective function value differently because it's not a constraint. It's an objective function number. Right now, that 46 is the current number times the optimal solution for that variable, 5 times 5. Current number with the other variable times the optimal solution for the other variable, 3 times 7. If this goes to 6, now it's 6 times 5, 7 times 3. Or, the quick way, $1 up times 5 would be an increase of 5. The new objective function value is now 51. You get it? A very common mistake here is, hey, this is changing. I'm going to look at this dual price, and I'm either going to add or subtract. Changes in the objective function have nothing to do with dual price. All these changes have to do with using the optimal values to figure out the objective function value. Changes in the right-hand side constraints always have to do with the dual prices. And the dual prices is what determines quickly whether that objective function value changes or not. Are you with me still? We're going to do another example. You ready? We'll do this one right here. Here's this. What's happening here is, remember this from chapter 2. We graphed it. We've got our objective function. We're moving out now. There was one of these two. Ends up being this one at 5, 3. Looks like this. When I set the objective function, maybe goes up or down. Hey, finance came in. We're not making $5 profit. We're making $6 profit. What's happening is the slope of that objective function line is changing just a little bit if either one of those two objective function numbers change. And it's like a teeter-totter hanging right there on that optimal solution. If the change in one of these two numbers causes that slope to go too far this way or too far that way, that is no longer the optimal solution. And that's why you have those ranges. Those ranges, the upper and lower limits, are calculated based on how far this could go. Now, I'm not going to go, I used to always show you how that's calculated, but I started to realize people hate that one. It's just confusing. So I'm just going to show it to you quickly. What you need to know, though, is if a change is taking place in the objective function, how to interpret it here. All right. Hey, head of finance just walked in and said, we're not going to make $7 profit on that second item X2. We're only going to be making $6 profit. My question for you is the optimal solution still valid, yes or no? Why? 7's going down to what? 6. 6 is within what? The limit, which means that's still valid. Help me calculate the new objective function value. 5 didn't change, times what? 5. 7 went to 6 now. 6 times what? 3. Add them together, there's the new objective function value. Because the change is with the objective function numbers. Yep, okay? Huh? What happened? Am I good? Okay? Let's keep going. How that's done to figure out those ranges for the objective function is where you have to take, oh boy, you got to find the binding constraints. You take the binding constraints and you take the numbers with the binding constraint, with the x1 and with the x2, and you put the first number as negative over the second number. And then you take the objective function numbers and make one negative over the second one. And you end up having something like this. Here's an objective binding constraints, 2 numbers. Matter of fact, you can't see it here. Again, remember these numbers. -2 and 3, -1, sub C over 7. Ready? Right here. -2 over 3, the number with the first variable over, turning negative, over the number with the second variable. This was a binding constraint. The other binding constraint was this one, I guess. 1 over 1, -1 over 1, because you got to make the first one negative. There's where the -1 came from. And then the objective function would be -5 over 7, but we want to solve for the 5. We want to see what 5 could go up to or down to, so we make 5 a variable. Hang on, you don't take notes on this. There's one binding constraint. There's the other binding constraint slope. There's the objective function, except we turn the 5 into negative c. And now we use algebra to get c all by itself. We multiply both sides by negative 7 to get that 7 out of there. Multiply that by negative 7, you get 7. Multiply that by negative 7, you get 14 over 3. And now the c, or the 7's gone, leaving you with just c. 5 could go up to 7 or down to, what is this, 4 point whatever, 4.67? And sure enough, 5 could go up to 7 or down to 4.67. And that's how that's calculated. And then you would do it again now for the 7. I'm not going to quiz you on how it's calculated, but you're definitely being quizzed on interpreting a change that's going to take place. You're going to be given an output, and you're going to see what the ranges are that go up or down to. And you just got told that the profit on that first item, X1, is going all the way up to $8 from 5. Is the optimal solution still valid, or do we need to stop production and recalculate? That's right, because 5 went up to 8, which was this one. 8 takes it outside the upper limit. These optimal solutions are no longer valid. The raw material that came in that we were expecting 19 pounds on, we got 22 pounds. Is the dual prices still valid for that constraint, yes or no? Yes, because 19's going up to 22, and we have an upper limit of 24. What's the dual price for this particular constraint? Positive or negative? Positive 2. How many units did we go up? 3 units. Times 2 is $6. $6 added or subtracted? Added, because of positive effect, because this was going up, which means positive effect, because this describes what would happen if it goes up for any of these. And this is a max problem, so we added it. You ready? Let's try one more. I want to make sure you're getting this. Hey, we had 8 pounds of this other aluminum, and only 7 pounds made. Is the dual price for that constraint still valid, yes or no? It is? It went from 8 to 7. What could it go down to and still have a dual price is still good? There you go. 8 went down to 7. But it could go all the way to 6.333. That, which one is this? This dual price is still valid. So how many units did it go down? 8 to what, 7? How many units is that? 1 unit times the dual price, which is a 1. Is that right? Yeah. So I have a $1 effect. Positive or negative effect? Negative. Why negative? It's a positive one. Because it went down. It will have the opposite. This is described, these describe what would happen if these went up. Because it's going down, the opposite. A negative effect. 1 unit change times $1 effect, negative effect. Do I add or subtract it to 46? Subtract, because it's a max problem. So a negative effect would be if it were going down. We don't want 46 to go down. We're trying to maximize this. Negative effect would be going down. I'm really emphasizing this because a very common mistake, no matter how much I'm emphasizing it, someone in here is going to make this mistake. No matter what I say, it happens. They quickly either add or subtract based on whether this is positive or negative without taking into consideration. This isn't telling you to add or subtract. This is telling you if you should have a positive or negative effect. You have to determine whether to add or subtract based on whether this is a max or a min. So sometimes this means add, sometimes it means subtract. It depends if this is a max or a min. Crazy, huh? Hang on. Let me see here. Where are we at now? I think we talked about the output parts. Range of optimality. Range of optimality is what is described right here. Range of optimality is the range in which the objective function numbers could either increase or decrease to and not have the optimal solution change. And still 5, 3 would still be our optimal solution. That's called the range of optimality. The word optimality always has to do with the objective function. Range of feasibility is all about the right-hand side of the constraint. Feasibility and constraints go hand in hand. And range of feasibility is what the right-hand side could go up or down to, and these dual prices are still valid. That's the ranges. Constraint 1, 6. It could go down to 5, or it could go up anything. And that dual price of 0 is still valid. Why is this 0? Why would that be 0? What is it about that constraint makes it different from the others? There's something about it. Non-binding. Look at the slacker surplus. Remember this from last week, or maybe even Tuesday. Every binding constraint always has 0 slacker surplus. 0. You can look at these outputs and quickly say, those 2 or that 1 or those 3 even are the binding constraints because their slacker surplus is 0. So constraints 2 and 3 are binding, correct? 1 being a non-binding constraint, it doesn't have a dual price because it has either slack or surplus involved. Its change would probably not have an effect up there because it wasn't what was determining the optimal solution. There's all kinds of play you can have in this one way or the other, and still, that dual price is still valid. All right, I think you're getting it. Here we go. We talked about dual price, you know what those are. What are dual prices connected to? Objective function or constraints? Not all, come on, that was one of those where everybody should have been there. I heard, thank you, I heard something. Dual prices are connected to constraints, always, and are not connected to the objective function. All right? Here we go. 100% rule of optimality, feasibility, 100% rule. They both are the same thing, but one of them has to do with the constraints. One of them has to do with the objective function. Obviously, optimality is all about the objective function. Feasibility is all about the constraints. Okay? Anytime that there's going to be more than one change taking place at the same time, do not assume that you can just jump up there and figure out the new objective function value. You have to figure out the 100% rule before you know if the change is valid or not. If it's a change optimality, you have to use the 100% rule if there's more than one change taking place before you can say that this optimal solution is still valid. In feasibility, these right-hand sides, if there's more than one change taking place on these, you've got to do the 100% rule before you can say these dual prices are still valid. Now here's the 100% rule. Let's pretend the current values in the objective function are 5 and 7, but finance just came in and said, we're not making $5 profit off X1. I got to write this down so I don't forget. We're not going to make $6. And X2, we're not making $7 profit on each one. We're making $8 profit on each one. My hesitation gave that away. Darn it. You heard it. All right. You ready? My question for you is are the dual prices still valid? No. Yeah, darn it. Let me make a better one. For all those who didn't see it right away, I picked a number that's outside. Whoops.
I wouldn't add it to dual prices, right? Second row.
Oh, yeah, thank you. Outside the upper limit. Did I say dual price?
Yeah.
My fault. I meant to say, are the optimal solution values still valid? And because the 7 is going up to 8, it's outside the limit. By the way, the first step on dual changes is to check if each are within their limits. And you have to write to show me you check that. You got to write both changes are within their limits if they are. Because if one of the changes are outside the limit, like this one is, you're done. There's no reason to go on any farther. You just write what is this connected to? The optimal solutions are no longer valid. One of the changes are outside its upper limit. And that's it. That's your whole answer. Now, I want to tell you something right now. I've never put a question on a quiz or final exam where the changes were outside their limits in a dual change. I want to see that you can do the 100% rule. So just to be safe, since you realize I'm not trying to trick you, and I almost, if I put a problem on there that's outside the range, I must have made a mistake. Because I'm not going to give you a problem that's outside the range. If there's a dual change taking place, more than one change. There could be 3 changes, 4 changes. Anytime there's more than one, you must do the 100% rule. So, let's change this now. We got that out of the way. Now this 7 is, I gotta look now. 7's going down to 6. We're going to have the same profit on each. One's going up, one's going down. Number 1, are they both within their limits? Yes. Okay, boom. 2, you calculate the percent of the change in the direction the change is going compared to how much change it could have went in that same direction. I don't know, what the heck did I just say? Are you ready? For example, the first one's going from 5 to 6, which is how many unit change? 1 over, in the direction in which the change is taking place, how many units could it have changed? That's right, 5 to 7 is 2 units. 1 divided by 2 equals 0.5. There's 1. 7's going to 6, which is how many units of change? 1. 7's going to 6, and it could have had how many units of change in that direction? 2. Oh, why did I do that? Darn. Now, you add up, if there was another one, we'd add that in too. We add up the percent changes that are taking place, we get 1.0, which is 100%, and as long as it equals 100% or less. If it were this area, we would say the dual prices are still valid. Since it's this area, the optimal solution is still valid. Because the changes are both within their limits, and the percent of change compared to how much they could have changed in the same direction is 100% or less. That's right on the nose, which I didn't mean to do, but it's still, yes. Now, you'll always be asked, what is the new objective function value? So here we go. Tell me what to do. What number should I use here, 5 or 6? 6 times what? Say it again. 5, because the optimal solution for the variable x1 is a 5. This went from 7 to 6, so 6 times 3. 5 times 6 equals 30. 6 times 3 equals 18. Our new objective function value is 48. One change is going down, one's going up. Our new objective function value is just a little above our current one. For those who want to take a shortcut, are you ready? 5 to 6 is 1. 1 times 5 is 5. It's going up. I'll add 5. 50, what is it? 51. 7 to 6 is 1. 1 times 3 is 3. It's going down. Now subtract 3. What was that? 51 minus 3 is 48. So you could do that shortcut if you want. I just like recalculating the whole thing because some people want it this way. Okay? All right. Everybody get this? Let's do feasibility now.
So for like what you did with like the 1/2 and stuff, so that's showing if so like the current value went to both current values went to one of their limits, then it would be over.
Yeah, that's right. If I had, that's right. If this adds up to over 100, you're going to say the combined changes are over the 100% rule, and you're going to say either, if we're talking about these, you're going to say the optimal solution is no longer valid. If we're talking about these, the dual prices are no longer valid.
So even if they're in the limit, both of them are still in their limits.
Both of them can both be within their limits, but if the combination of the changes add up to more than 100%, these numbers are no longer valid. You have to redo the whole problem. You're going to have a new optimal solution. It took it out of the possibility of that extreme point being the optimal solution. What are the other extreme points of the optimal solution now?
Are you going to post this under the material for chapter?
I think it is. What are we talking
Well, there
about?
was 2 of them that I tried to select just now before the class started.
Here.
It won't open it up.
It won't open. What?
It opens up very weird. Oh, wait, maybe it's...
This is it, right here. Now look at, I want to point this out. This is that set 1, x1 less than equal to 6, 2x1, 3x2 less than equal to 19, x1 plus x2 less than equal to 8. The objective function values are 5 and 7. That's the problem, right?
Yeah, so when
You ready? Oh, I'm sorry.
So when I clicked on the chapter 3, the Excel that you posted, it says the specified resource was not found, or I do not have permission to access.
Oh yeah, I'm going to check that for class. I don't know what's going on. I've never had that happen. But okay, here we go. Let's see if we can remember how to do this. Data, is that right? Solver. Well, look, we got a blank one. How lucky are we? Okay, set objective. What word did I tell you to replace on that in your notes? Set objective, so that when you see this, you're going to see a picture of this on your quiz maybe, and I'm going to tell you, what would you put in set objective? Looking at the spreadsheet. Huh?
Objective function.
Objective function is the words. Now, the cell location, please.
E16.
E16, there it is. I don't want to type it out. I just click it. E16. Max or min?
Max.
Max. I'm making sure max is checked right there. That says by changing variable cells on your notes, I tell you to change those words to what?
Variable solution.
Where the solutions are, where the optimal values are going to be placed, which says variable solution right there. So we're only using these two. So I'm going to highlight these two right here, E14 to F14, E14 to F14. Now our constraints. Are you ready? I'm going to add a constraint. Our constraints are all down here. Remember, don't change any of this. Just input your data up here. This is what you're changing when you're using, if you want to use the Excel spreadsheet I posted for you, save you a lot of time. Here we go, add. The first constraint, left-hand side is right there, is less than equal. The right-hand side is right there. I'm going to add a constraint. The left-hand side is right there. It's a less than equal. And the right-hand side is right there. I'm going to add a third constraint. The left-hand side is right there. It's a less than equal. And the right-hand side is right there. I'm going to click OK. All three of them look good, right? 2021, 22, 2021, 22. Do I check this box?
Uh-huh.
Yes.
Very good. Is this correct right here?
Yes.
Very good. Am I done?
Yep.
Ready? If this worked, what should show up right there? There.
Two numbers.
Yeah, that's correct. That's right. Now, if I gave extra credit, there's some that needed real good. My question for you is, what will show up right there and there? 5 and 3. What should be right there? 46. 46. You ready? Here's the word. Now this goes real fast, and then it puts something there that says okay. Just save yourself time to say okay. 5 and 3, 46. We all can solve these using Excel. You've seen this 3 to 4 times now, right? The only thing that's going to be happening in our feature is you're going to have more variables than just 2, and you're going to have more constraints than 3. You just insert another row, insert another row, insert a column if you got to go past 5, and so on. Go ahead.
I did figure it out. Where did
It is opening now?
Yeah, I did.
Okay.
Yeah. Where did you press again though to pop up that problem solver?
You got to go to Data,
Yeah.
and then you got, and that solver, if it's not there, you're going to have to install it by going File, Options, what is it, Add-in, you guys?
Yeah.
Add-in, and then you got to go down to the bottom here where it says Manage Add-ins. You with me right there? Hit Go. You see this at the bottom? And then click the box for Solver Add-in right there, and click OK, and give it a couple seconds to install, okay? All right. How we doing? You ready? Let's do feasibility now, 100% rule. Where's my output? Is this it? Where's my, there we go. Hang on, let me get back here. Okay. We're focusing on just one on purpose, so you guys can get the hang of this. Because what I'm teaching on this one applies to any output you see. 100% rule now on feasibility. Same logic, all right? Hey, we got 2 of our limitations are changing. Instead of being 19 and, I want to see the dual prices here. Instead of being a 19 and an 8, is that an 8, right? Instead of being a 19 and an 8, hang on. This is weird eraser. Okay, 19, they dropped off some extras going up to 20. Okay. And the 8 is going down to 7. Number 1, I hope you got this in your notes. First step, and when there's more than one change taking place, is are they both within their limits? Yes. 19 is going up to 20. It could go to 24. It's within its limit. 8 is going down to 7. It could go to 6.33. It's within its limit. This amount of change, 19 to 20, is 1 over. 19 could go up to 24, which is 5. Help me out here. Is that 0.2? Thank you. 8's going down to 7, which is 1 unit. How many could it go down to? 1.6. Is that it? 1.666? Let me just look here. 8 minus 6.33 would be 1.67. 6666. Give me a. This equals point. Where's my cut? Siri. What's in my pocket? Hang on, you guys. Come on. Give me a number here. 1 divided by 1.6. Calculators. They're all over here.
0.625.
0.625.
Yeah.
0.625. 0.625. Here we go. I'm adding 0.625 to 0.2. I get 0.825. Does that sound right?
Yeah.
I need to, as showing my work, I'm going to put less than 100%. I'm showing that I'm comparing it to 100%. Because it's less than 100%, that means what when we're doing a feasibility 100% rule? What does it mean now?
Within the limit.
So say it again.
Within the limit.
They're both within their limits. That was step one. Then we figured out how much they've changed compared to how much they could. And we're under 100%, but what did it tell us now that we're under 100%? No. Oh, yes. Yeah. If this would be telling us the optimal solution, but down here, these are all about the dual prices. Very common mistake. Thank you for doing it. Appreciate it. So we can point out. So your words here would be the dual prices are still valid. That's what we did the 100% rule. And you're always, the next sentence on your quiz is going to say, if the dual prices are still valid, what is the new objective function value? You ready? What's our objective function value now? 46. I'm starting at 46. I don't know if you guys can see this. I'm going to the first constraint right-hand side. It's going from 19 to 20. 19 to 20 is 1 unit. The corresponding dual price is a 2. It's going up. It's a positive 2. It's only 1 unit. 1 times 2 is 2. Do I add or subtract? Add 2. I'm at 48. The other change is going from 8 to 7, which is 1 unit. The corresponding dual price is positive 1. We have to do the opposite of the positive effect, which would be negative effect. 1 times 1 is 1. Am I adding or subtracting 1? My new objective function value is 47, and the only reason I calculated that is because each change was within its limits, and each change is percentages compared to how much they could change in the direction the change is going, add up to less than 100%. Now I want you to be careful, because you're going to be coming up to where there's 3 changes at the same time. Nothing changes from what we did other than you're adding a third one here, and you're adding all 3 of them together, and they got to add up to less than 100% for these changes for the dual prices to be valid, or if there were 3 of these, for the optimal solution. Here, it's all about if the optimal solution is still valid. Here, the right-hand side of constraints are all about the dual prices still valid. No matter what the change is, no matter where it's taking place, it's affecting that objective function value. And you will always be calculating what's the new objective function value on the quiz. That's the bottom line of all this. It's showing your work. Man, that was a lot. You know what? Thank God we're recording this. You know, because this is the one to review. We will get into output analysis for decision making deeper, a couple more softwares and another example. And what I don't have up there, which is really important, is, hang on, I can't think of it. It's called, right here, relevant cost and sunk cost. This is what's heavily used in decision making, right here. It's all about kind of like this. Whether it's a relevant cost or a sunk cost, you can then make the decision whether you want. Suppliers are calling you. You guys are a buyer. You got a job down in Detroit where all those tier 1, 2, 3 suppliers are for the 3 big car makers. And your job is a buyer. You're getting called by suppliers all the time. Your company's constantly making different things, and that supplier just offered you 2 more units of aluminum. And that supplier needs to know right now if they should ship it over because they're in your area and they have 2 extra ones that their other customer didn't take after they already dropped off 8 this morning. And you're going to try to determine whether that cost is relevant or sunk. So you can say right there on the spot by analyzing your output, bring it over. We'll take it. Bill me. Or not. No. Forget about it. We'll offer it to someone other something. Okay? Or negotiate. That makes me proud of you. Negotiate. All right? You don't say no right away. I could take it if you took it down to, but what you're about to say to negotiate is all based on your analysis, whether it's suffer or a relevant cost, and how it compares to this area right here. This is telling you whether you should buy it or not with a little math involved based on what kind of cost. And that's where we're going to go on Thursday. Where's the sign sheet? Okay, guys, have a great weekend.